In this lesson, we're going to put together a factoring flowchart that will hopefully help us decide which type of factoring, remind us of how to factor, and then be able to work through a bunch of factoring problems. So there's a printout that a handout I would print off if I were you. It has the whole flowchart on it. We're just going to add stuff to it, just to make your life a little bit easier. So first thing we want to do when we start factoring is we want to identify which type to use. We always start with common factoring. Do this first. Common factoring can be combined with lots of other types of factoring. But if we miss the common factoring, our final answer sometimes is not factorable. So we should always start with common factoring. Okay, just take out the greatest common factor. So in this example here, we see there are 4m squared in common, and we'd be left with a 2m minus 1. Now the question you want to ask yourself is, can I go further? So there's a little rule for us. In order to factor something, a little star here, the highest exponent must be even for us to go further. So when I look at the bracket after my common factor, and notice my highest exponent is 1, that tells me I can't go further. Now notice I did this after I common factored. Okay, so in the original equation we have a power of 3, but I can factor that by common factoring. When you're done, check your brackets. Are there even exponents? If so, maybe you can go further. What can you do if you want to go further? Well, there's some choices. First thing you should probably do is count how many terms you have. Okay. So if we have 2 terms left over, like the previous example, it couldn't be factored, no even exponents, but there was 2 and there was an even exponent, you have to ask yourself 2 questions. Question 1 is there a minus sign? Well, if that's true, check the next thing. Can you square root both terms? If that's also true, then you have yourself a difference of squares. And like this example, a difference of squares, we take our 2 brackets, and we square root both terms. So square root of 81k4 is 9k squared. Square root of 1 is 1, and we put opposite signs between them. And then you have to ask yourself, can I go further? So check, do you have even exponents inside your brackets? And in this case, I do. I have even exponents inside both brackets. I might be able to go further. So I start my flowchart all over again. I count my number of terms. I notice I have 2 of them, but I got a plus sign, so I cannot go further with that bracket. I check the next one. I've got 2 terms. I've got a minus sign. Can I square root both things? I can, which means the second bracket can be broken down further. The first bracket's going to stay exactly the same. I cannot go further. It had that plus sign in there. But the second bracket is itself another difference of squares. The square root of 9k squared is 3k. The square root of 1 is 1. And I put opposite signs between them. And then I start my check all over again. I count my number of terms. 2 terms. Well, we already know this one can't go further. So let's try the next one. 2 terms. Oh, but there's a plus sign. 2 terms. There's a minus sign, but I have non-square rootable terms. In fact, I don't have any exponents left, right? There's no exponent right there. That's kind of a hint. I cannot go any further. So this difference of squares had itself another difference of squares inside it. That's a question you have to ask yourself about, when can I go further? Okay, back to our chart. So, what can we do next? We could have 3 terms. Question you want to ask yourself here is, do I possibly have a perfect square? Because if so, there's a shortcut. I always said you don't have to know the shortcut. It's just helpful. It's a shortcut. But it saves yourself some time rather than having to do complex or simple trinomials. So the question you want to ask yourself is, if I square root the first term and the last term, and I double it, does it equal the middle term? If so, it's a perfect square. So for example, this next one. Can I square root 4m squared? Sure I can. Can I square root 25? Sure I can. And 2m times 5 doubled comes out to 20m. which means it's a perfect square. So put the square on it, put your sign on it, you're done. That's really quick. I like that. If I didn't do it that way, I'd have to do a complex trinomial. It takes me a lot longer. Okay, but if you can't recognize it, it's not the end of the world. Okay, so the question was, does the middle term equal this? Well, what happens if it doesn't? We have two choices. Choice number one, is the value in front of your squared term 1? Okay, now remember, we've already common factored, so you might have not had it originally as a value of 1, but at this point, if your term that's squared has a 1 in front, that means you have yourself a simple trinomial. That's our MAN process. What multiplies to negative 100? What adds to 21? Well, the numbers that do that would be 25 and negative 4. And simple trinomials are just a single step. So C plus 25, C minus 4. And then check your brackets. Can you go further? I hope you notice right off the bat as we have no exponents, there are powers of 1s, that tells us we can't go further. We're done that one. Simple trinomials. Well, we had to ask ourselves at the beginning of that, is the number in front of the square term 1? Well, what happens if it isn't? Well, the only thing we have left is a complex trinomial. In this case, the number in front of the square term isn't 1, it's 4. And it can't be common factored out. Plus, we've already done common factoring. So we have to approach this in a complex way, the MAN plus. Reminder, we multiply first and last. We get 12. We need to add to negative 7. Our numbers that do that are negative 4 and negative 3. And this is the procedure one, right? We replace the middle term with our two new terms. We split it in half, and we common factor each half. You know you're on the right track if your brackets match, which they do. And you have your complex trinomial. A couple of little hints, reminders. That sign always goes down there. Okay. I like to put the big number first, the small number second, but it doesn't make a difference. There's a complex trinomial. Okay, so we have three types of expressions that have three terms. The perfect one, the shortcut, the simple one, just a regular squared term, and the complex one, a number in front of your squared term. If we don't have two terms or three terms, we might have four or more terms. In this situation, we go back to the idea of grouping. Is there a way we can common factor each half of the equation? Now, for these kind of things to work, you need to have an even number of terms, 4 terms, 6 terms, 8 terms, and so on. Okay. So even though these don't have an exponent on them, I'm going back to the idea of common factoring. I don't need to have an even exponent to common factor. I just have to take something in common out. So if I split it in half, I can take an x out of the first two things. If I split it in half, I can take a y out of the second two things, and I can carry down my sign like we've been doing. And I notice that, hey, I have a group that's common. And I can write it sort of in the way we did a complex trinomial, common factoring out a group. And those are our different types. If you weren't able to do one of those types, then for our purposes right now, we can't factor. Yes, there are other types of factoring. We're going to worry about those in grade 11, higher functions next year. But for us, our purposes right now, we're done. Okay, let's try some examples. Here's where I would pause the video, try them all yourself. Check back in, see if you got the examples right. There's no new learning here, it's just practicing the different types. I'll go through each of them. The first one is a simple trinomial. There is no common factor. The term in front is a 1, so I can simply do MAN x plus 3 and x plus 8. In the second one, I look for a common factor. There isn't one. I count my terms. There's 2 of them, a minus sign in the middle, and I can square root, which makes it a difference of squares. I can't go any further because I have no exponents. The third one, I see a common factor. I can take a 3a out of both things. I'll be left with 2a minus, missed the 3 there, 2a minus 3b. Inside the bracket, there's no exponents. Can't go further. Letter D. I look for a common factor. There isn't one. I notice my term out front is bigger than 1. That makes it a complex. So man plus. Multiply to negative 60. Add to negative 11. Numbers that do that are negative 15 and 4. So we're going to replace. We're going to split it in half and common factor each half. We're going to notice we have a common bracket that's the same, so we're on the right track. And the leftover stuff goes in the other bracket. Letter E. Okay, there's no common factor. There's 3 terms. I'm going to try and do my perfect square this time. I notice that because I know I can square root this number and I can square root this number. So if I try it, 2a times 5 is 10. Doubled makes 20. It's a perfect square. I didn't do that in the previous question because I noticed that neither 6 nor 10 are square rootable. That's the kind of thing you want to look for. And letter F, I notice they can all be divisible by 3, so that's common factor first. I check my brackets. I see an exponent that's even, so I say to myself, I've got 3 terms, nothing in front of this squared term. There's a number 1 right here, so it makes it a simple trinomial. What multiplies to 72 and adds to 1? Negative 9 and positive 8. Okay, notice the 3 is still in that line, so I can work forwards and backwards and make equivalent functions. And last 6. Letter G. Now letter G, I kind of messed with you a little bit. It's not in the right order. We always want our highest exponent first, and then our next exponent, and then our last one. We know we can move things around algebraically as long as we don't change our signs. Put it in the right order. There is no common factor. It's a simple trinomial. We need to multiply to 18 and add to negative 11. Our numbers that do that are negative 2, negative 2, and negative 9. Okay, so simple trinomial, a minus 2, a minus 9. Letter H. It's common factorable. They can both be divisible by 5, so let's take that out. I look at my bracket and notice there's an exponent. In fact, an even exponent. It might be able to go further. There are 2 terms. There's a minus sign in the middle, and I can square root both of them. That makes it a difference of squares. I check my brackets again. No exponents. I'm done. And letter I. I'm looking for common factors. Some of them have x, some of them have y, but nothing in common altogether. I look at my first term. It has just a 1 in front. That makes this a simple trinomial. We're doing man. We said the other day these ones cause confusion sometimes because of these letters. So let's deal with the letters first. To get x squared at the beginning, I need x's. To get y squared at the end, I need y's. So when I multiply now, I need to multiply 12, add to negative 4. My numbers that do that are negative 6 and 2. And there's my simple trinomial done. Okay. Take care of the letters first, and then deal with the numbers. Okay, letter J. No common factors. 2 terms. Minus sign in the middle. Can I square root x4? I can. Half of that is x squared. Square root of 256 makes 16. 1 plus, 1 minus. Check our brackets. Can we go further? They both have exponents that are even, so maybe. The first bracket's got a plus sign. Can't go further with that. The second bracket has 2 terms with a minus sign, so I can go further. I'm going to rewrite the first bracket because I can't touch it and I can't change it. But the second one, I can do difference of squares again. X plus 4 and x minus 4. I can't go any further because my new 2 brackets don't have exponents on them. Letter K. I'm looking for a common factor. I notice they're all divisible by 3. I also notice that I have an x and a y in all 3. And what are we left with? We're left with an x minus 2y plus 3. Check my bracket. Can I go further? No, because my exponents are odd numbers. Don't have any even exponents. And last one. Common factors. Oh, they're divisible by 4. I also notice I have an x4, but no x's anywhere else, so I can only take out the 4. So we're left with x to the power 4 minus 10x squared plus 9. Check my brackets. Can I go further? Well, it kind of looks like a simple trinomial, except it has a power of 4 on it. So how would I approach that? Well, if I treat it like a simple trinomial, but instead of having x's at the beginning, I have x squareds, and I think about FOIL, x squared times x squared would make x4. So this will work. Can I multiply to 9 and add to negative 10? Sure I can, if I use negative 1 and negative 9. And then I check my brackets. I notice I got even exponents. I might be able to go further. Both of them have 2 terms, both of them have negative signs, and both of them are square rootable. So in this one, I'm going to move it over a little bit to fit this in here. I can do a difference of squares with that piece and that piece. Get rid of this arrow. X squared minus 1 will become x plus 1, x minus 1. And x squared minus 9 is x plus 3 and x minus 3. Okay, that's factoring. All the different types all mixed together. Kind of a really important concept because we're going to be doing this with all kinds of different situations. We're done reviewing this. We're going to just be part of our day-to-day math now. We're going to do lots and lots of factoring. Okay, some questions to try. You should try them all. You've got to be real quick at them and be able to do them without having to look back at your flowchart every single time. Down the road, we won't have our flowchart. We'll just factor. And if you're stuck, come see me and we'll figure some stuff out.